Then we applied the occluding contour algorithm. So we chose these contours, and the computer puts in the red lines. And look how well they meet at the candle. This is, to me, really quite impressive. Think about this contour on his shin. The computer doesn't know anything about Baroque art, doesn't know about Christ, doesn't know about biblical stories, anything like that. It has a curve and a pattern of lightness along that. And going through the mathematics, it says, you know, the light source is in this direction. Bingo, right at the candle. I find this really quite amazing. I'm a fourth-rate painter, and I can get contours reasonably well, but to get the shading so accurately is really, really quite impressive. And you can do the same kind of a posteriori probability density estimation, and it goes right there at the base of the candle. Now, you see the white here, that's actually smoke. The flame itself is right behind Christ's hand, so it's about as good as you could possibly get. Really, really quite impressive. We've done it on other paintings, now than the smoking flame in the Los Angeles County Museum of Art, and it's really quite close to the candle. One of the benefits of using this probabilistic approach is that we can integrate, or we can put together the estimates made through different methods. So here's the cast shadow evidence I showed you. Here's the occluding contour evidence I showed you for light passing right to left. And to put the evidence together, you just multiply those two densities, those two high pressure regions, if you will. And you get something like this, very close to the candle. Certainly not in place of Christ, and certainly not outside the frame of the painting. There's another source of lighting evidence in the painting that we have not yet shown, exploited, and that's the pattern of light over the floor. Notice it's brighter in the middle and darker over here. So the light's got to be somewhere around here. It's not going to be over here, of course. We want to take this evidence here, the lighting evidence on the floor, and find the best position for a candle or point source in this entire tableau. Well, here's a model of the room. Here's the point source, the light, and we find the brightness at a given point here in the room, x, z, in given positions here. Well, there's going to be a 1 over r squared fall off. Everyone in physics knows this. Then there's the Lambert's cosine law based on this, and then the overall reflectivity rho. That will determine it. But that was in the room. We care about the position on the painting. So the left-right coordinates can be called the same, but the distance back in the room is related to the position up and down in the painting by a trigonometric function. It just tells us based on the tip of the floor, and we don't yet know what phi is, this angle phi is. And I won't go through all the math, but we can make a model of the brightness for a given row, given h and phi, and it goes like this, and that's that. And what we want to do is take the measured position in the paintings for all part of the floor. We can measure the brightness at position x, y in the painting. And then we can get our model. It says how bright it'll be in a position x, y for a given row, a given h, and a given phi, and adjust these to make this as similar as possible to this. Minimize the squared difference, the mean squared error it's called. And I won't go through all the math, but there's real math here, and you have to do gradient descent. Anyway, here's the effect of changing the albedo of the floor, maybe from black to gray to white. Here's the effect of raising the height of that point source. Notice it can sometimes get brighter here, even though the light source gets further away. It's because of that cosine term gets larger. And here's the effect of the tip of the floor. So those are the three parameters we have to search through in order to explain the pattern of lightness on the floor in that painting. And when you do that, you find that the light source that best explains this pattern is around here. Now, it's not exactly at the candle, but it's a better explanation than if it were in place of Christ or St. Joseph, or certainly outside the frame. And we now know, I'm working with a computer vision graduate student at Stanford on this, why it's low. And we think we're pretty sure that it's for the following reason, that the range of lightnesses to which our eye is sensitive and which we experience in the world is much, much larger, maybe a factor of 10,000 or 100,000 in such a room tableau, than the reflectivity we can get in paint. The whitest white paint is only a factor of 100 brighter, more reflective than the blackest black. So you cannot express that, even if you wanted to, using paint. And that, if you go through the math, just shifts the position of the estimated light source. And I won't go through the others. If you do just 1/2 and 1/2, it doesn't explain the data nearly as well. But there's other lighting information in that tableau we haven't exploited. Think of the pattern of light over Christ's chest. That's not on an occluding contour. That didn't cast a shadow. So just as with the girl with the pearl earring, we have to make a computer graphics model. So here's our wireframe. And then we're going to render the scene with the light source in place of St. Joseph, and then in place of the candle, and we're going to render Christ and see which one best matches the actual painting. Problem is, we don't know the depth into the painting where we should put our light source. So here's a bird's eye view or plan of the tableau, and we've tried 19 positions with the light in place of St. Joseph, 19 with it in place of the candle, and we chose the best one from this and the best one from this, and then we compared the two to see which one best matched that in the painting. So here's the our computer graphics movie. If you've taken our history course, you'll realize we taught the symbolism of the tools is St. Joseph passing worldly knowledge to Christ. Christ is the light of the world. He's a candle, holding a candle. And it's hard to see in this projection, but the cast shadows are changing as we adjust the position of the virtual illuminant into the plane of the painting. And now we can turn it around, look at it from the back, so to speak, and we're going to stop it in the configuration that best matches the actual tableau. We do an alpha blend, a blur into the painting, and it matches really quite well. So here are this is the best image we could get with the light in place of St. Joseph. This is the best we could get with the light in place of the candle. We have to say which one best matches the actual painting. And there's no question, none at all whatsoever, that the case with the light in place of the candle better matches that of the actual painting. Look at the pattern of light over Christ's chest. That matches, this doesn't. Look at the direction of the cast shadow of the shin. In the model it's like this, and in the painting it's like this. Not exactly the same. It's a painting as well, but much, much better than over here, and so forth. If you take your time, there's no question that the explanation of the light in place of the candle better explains the tableau itself. We've applied this to other paintings. Caravaggio's The Calling of St. Matthew. You do a cast shadow analysis to say, oh, the light source might be here, but you can do the same kind of pattern of analysis, the pattern of light on the back wall, and you find that the light is probably somewhere over here. And this is another painting that Hockney believes was done under illumination, under projection. But if it's a local light source, it would have been some sort of candle or some flame, and hence too dim. So Hockney says it must have been sunlight, and is it possible that sunlight could explain the pattern of lightness here? It's bright here and dark over here, and the source is equally far away, and the angle is the same, so that alone wouldn't explain it. So the only way you can get that kind of fall off is if the back wall is not Lambertian, if it's not diffusely reflecting, but has some sort of gloss to it. So we made a very sophisticated computer graphics model with the Bornage of Sony Entertainment Research. So some of you students are probably playing games that he rendered things on, but now you get to see something really fun. Anyway, so the reason we can now do this is that in his modeling, we can adjust the reflectance properties of the wall to go from, gradually change from being a diffusely reflecting surface to being a mirror-like reflection, and see if we can get this kind of fall off with sunlight as the illuminant. Here's another view into this tableau. And when I showed this at the Renaissance Society of America, the other art historians, ones who didn't care about lighting, said, oh, we've always been wondering who could see whom, could Christ see this, and so forth. So now they're analyzing our computer graphics model for other reasons that we had never even started to think about. Who could have seen whom and things like this. So here's our tableau, and now, and it matches the painting really quite well, as it has to, as it's designed. Oh, and I should say that all of physics is included into that model. So things like the size of the illuminant, if it's a small angular subtense, it means that the shadows will be nice and sharp. As the light source gets larger and larger, we get what are called penumbrae, the blurry partial shadows along the edge here, and that's included, and that gives us information about the size of the light source and so forth. But we wanted to model the physical properties of the wall. So here, we do that with what are called BRDFs, bidirectional reflectance distribution functions. So the blue square is the wall, and this line here, VI, the incident light comes like this, and this purple tells us where the light is coming out where it reflects for a specular model, like a mirror. And here it's the angle of incidence equals the angle of reflection, just as you all know. The other extreme is Lambertian, so in comes the light, and it can reflect off in every direction equally well. That's that cosine law. But there are intermediate models, for instance, the Cook-Torrance model, which is really just a model of lots of little surfaces at different angles on the microsurfaces, and you can adjust the parameters. And in this case, light comes in, and mostly goes off in this direction, none comes back this direction, but it's more like, think of a glossy wall. If you get glossy paint, that's much more what this explains. And so we wanted to know whether we could explain the pattern of lightness on the back of that wall, the Caravaggio wall, with a Cook-Torrance model and sunlight. So here is the Lambertian model. And so we adjusted the position of the light source until this rendered wall matches the actual painting. And what we found was it's almost exactly the same position as I had done in an earlier paper, just doing that mathematics of the physics and then computer graphics reconstruction. So that sort of shows the agreement and commensurate nature of these. And then we wanted to see if we could get sunlight. So here's the solar illumination model, and you can indeed get some fall off using a Cook-Torrance model. So it's brighter here and a little bit dimmer here. It's hard to see on this projection. But when we did this model, we saw something that apparently no art historian had ever written about or thought about, and it is this shadow here. It's an upward moving shadow. How can you get an upward moving shadow like that if the sunlight, you can't with sunlight, or not directly, it's not cast shadow from, for instance, a window here, something going up like this, because that would mean the sun has to be down below, something like that. You can't do it. So the only explanation we could come up with was that there was part of the roof outside Caravaggio's studio that was at an angle, and that can indeed give you this upward moving shadow. And when I showed this at the Renaissance Society of America, the architecture historians all got together and said, oh, well, gosh, I wonder whether his studio might have had something like that, and now they're all debating it, so I don't know yet their answers. So we haven't, in some sense, pinned it down, but we're refining it and getting better questions that will be able to help us pin down the answer to that question. Now I want to switch gears and talk about a painting that has nothing to do with the Hackney debate, at least not directly. Las Meninas is one of the most important paintings in the Western canon. You could read books and books and books just on this painting. I wish I had time to take an art history class and you'll learn a lot about it. But the technical question we addressed is the following. There's a plain mirror on the back wall in the tableau in the studio here that shows the king and queen. And the question is, are we, the viewer, when we're looking at this painting in the Prado, when we stand at the proper position, are we seeing ourselves reflected in the mirror or not? And that affects the meaning of the painting and the interpretation of something. Well, the way we did it, that we addressed that problem, was by building a computer graphics model. So here's our computer graphics model, and now we can look at it from lots of different positions. Oh, and we know the scale of the room because those paintings that are depicted within the paintings are fictitious. We know how big they were and so forth. Here's the king and queen standing there. So we can look from lots of different directions. The mirror works, it reflects light in the tableau virtuelle, as I call them. And they match well as they must. And here is our result. Here's the bird's eye view. Here's the proper position for the viewer who can look down the staircase here, something like this. And when they're looking at the mirror, what they're seeing is actually not themselves, but the other side of the canvas. They are not seeing themselves. And so we made a fake painting using Photoshop to be consistent with the mirror image that we find in Las Meninas. Now, I've shown this to Velázquez scholars, and we don't believe that there was ever really, and they said they've never seen this kind of portrait, this particular portrait, and certainly not at this scale, which would be necessary. So we don't believe that there really was this image there. Instead, Velázquez just painted the king and queen in that mirror, and this is just one way to sort of illustrate that, that he was really looking at the canvas and not seeing, we are not seeing ourselves reflected in it.